All right, this video is a continuation of the previous video on empirical formula. This video is about molecular formula, which is a whole number multiple of the empirical formula. So keep in mind that the empirical formula is the smallest whole number ratio of elements in a compound. So notice 1 to 1, those numbers cannot be reduced. So if you're a math type of person, you can think of this as the reduced fraction. What we're going to do in this video is figure out what is the actual representation of the molecule called its molecular formula. So this will tell us actually how many of each type of element is really in the compound given its molar mass. So we have to be given this molar mass. So what we're going to do to figure this out is we will take the molar mass and divide it by the mass of the empirical formula. So first, you'll need to have the empirical formula, which we solved from the last video, so watch that one if you missed that. We're going to use that formula and calculate its molar mass, just like we've done before in regular molar mass problems. So from CH2O, we're going to add up those masses. So carbon is 12.01. We have one of those. Hydrogen is 1.01. And we have two of those in the formula. And then last we have oxygen, which is 16.00. Okay, those are all the elements in this compound. So we'll add those up. And we get 30.03 grams. So that is the mass of our empirical formula. What we're trying to figure out is what whole number we need to multiply this formula by to get the molecular formula. The molecular formula is some whole number multiple of this formula. Okay, so what we can do is just divide. We're going to take the molecular formula mass, the mass of the molecular formula, and that's given to us in the problem. They say that the mass of the molecular formula is 180.0 grams. And then we're going to divide that by our mass of the empirical formula. And this is going to give us some whole number. And we usually use the variable n to represent that. It's just some number that we're going to use to multiply all of the subscripts in this formula. Okay, so the formula for that is to take the mass of the molecular formula and divide it by the mass of the empirical formula. So the molecular formula mass is always going to be bigger, right, because it's some multiple of this. So the bigger number goes on top, smaller number goes on the bottom, and that will allow us to get a whole number. If we put the bigger number on the bottom, we'd get a fraction, right? So the bigger number goes on top, it's the molar mass of the molecular formula. And if we did this right, we will get very close to a whole number. This is a nice type of problem because if you don't get a whole number, you did something wrong. There's no multiplying by 2 over 2 over 3 over 3. That's not allowed here. It is some multiple of this. So when we type this into the calculator, we should get a whole number. And remember, it just needs to be within a tenth of a whole number. So 5.99, very, very, very close to the whole number 6. So what that 6 means is that the molecular formula is 6 times the empirical formula. So all we need to do is take that empirical formula, and we're going to multiply all of the subscripts in the formula by 6. So previously we had 1 carbon. In the molecular formula now, that means we have 6 carbons. Previously, we had 2 hydrogens in the empirical formula. We're going to multiply 2 by 6, so we're going to get 12 hydrogens in the molecular formula. Oxygens, we had 1. We're going to multiply by that by 6, so we get 6 oxygens in the molecular formula. So now, we get the molecular formula of the compound. And if you wanted to verify your answer, you could. You could take this formula, add up all of the masses, calculate the molar mass of this, and you should get 180.0 grams. That was the mass that was given to you. Okay, so pretty easy last step. If an empirical formula problem turns into a molecular formula problem, you just need to figure out that whole number ratio and then multiply that by the empirical formula. Okay, so good luck with your homework.